In this exercise, we're going to be discussing calculating the physical properties. Basically, if you come in here and right-click and go to iProperties, click on the Physical tab, you can actually see how much this machine is going to weigh. If I close out of this, and I go into this part, say iProperties, Physical, it tells me that this is 1,500 pounds of steel, basically. It's high strength, low alloy, and all this information. Notice I can't change any of these other than the requested accuracy. Because I'm in an assembly environment, I can't modify that. If I right click on this and say open, I can right click again, go to iProperties. And now I can change from low alloy to carbon to these different densities and have different weights based on that. If you don't change the material type, you will not get the right information. I've seen a lot of people that will take and model everything up and leave it at default, and then they'll be like, oh, the steel doesn't weigh right. Well, it's because you got to tell it that it's steel. It doesn't know how to read your mind and tell that it's steel. So you come in here, you set it to be steel, you hit OK, save it, you go back to the assembly environment, so now your assembly is correct. And you'll notice that I left this cut in half so you can see what the assembly section does to the weight. 56, 125, 669. I come over here to view, and I turn that off. Go back to physical. You'll notice that nothing happened. It's because that assembly section view doesn't actually do anything to the part. It's not actually cutting it in half. It's just turning things on and off. So it still calculates it. If you come in here to a subassembly, you can see how much the subassembly weighs, and so on and so forth, all the way down to the part, of course. If you buy something, so for instance, I come in here and I go to the iProperties of this big roller, it tells me it weighs 25,000 pounds. We buy this roller, and I just modeled it as a solid. Come back over here to my section view again. Just because I'm not going to spend a whole lot of time remodeling something that I'm going to turn around and purchase. But I know that they don't really make these things out of solid steel. They make them out of some kind of layers. They may fill them. They may be hollow. These little shafts like this aren't going to hold a 25,000 pound, 24-inch diameter roller, especially if there's something going through here. So what you need to do is adjust the weight of these rollers to what they actually are. So if you buy something from Grainger, or you go out and you order something from somebody else, what you can do is you can come in here and override this inside of the part. So I could say open, go to the iProperties in the part. I don't really care what the material is, because I'm not going to model this exactly. Say it's 2,500 pounds according to Grainger. You'll notice right away I get the little hand here, and to me it looks like somebody's sitting there tapping their fingers. So it tells me that, hey, I've overridden this. This one's calculated, this one's overridden. If for some reason I wanted to get rid of this, I just highlight it and delete it and say update. It'll go back to just being good old-fashioned calculated. But I'm going to override this, say apply, close this out. Now if I come back over here to my machine, look at the properties of it, you'll see that it's saying lost like 40,000 pounds. So it has two of these big rollers on them that were like 50,000 pounds each. No way that that's 50,000 pounds. This thing's 2,500 pounds. So now I get a little bit more accurate. One of the perfect examples of this is I work with a company that designs monitor lifts for TVs and LCD monitors. Well, I'm not going to take the time to model every single little circuit, every single solder, chip, everything inside of that LCD monitor, get the weight just right. Weight's very important to us. So instead of going through all that trouble and modeling this TV or computer monitor exactly, you know what I did? Went and looked at the box. Box tells you right there on it, this computer monitor weighs 12 pounds or whatever it weighs. Come in here and overrode it. And now I can do calculations. I can actually do simulations and see what's going to happen to my lift when I lift it up and down with that. And I can even have it be solid. I can have it be a dumb block. You know, I did make it look a little bit like a computer monitor, but I didn't have to take the time and make it perfectly beveled exactly the way it is, because I just want the generic size and shape of it and then how much is it going to weigh. Now it tells me here that this is the hand and the calculator, so some of these are real, some of them are overridden. So it's pretty straightforward. You can do a lot with this, and it's very, very accurate. I had one engineer tell me that a design from 1939 was off in Inventor because it weighed a different amount. It was 120,000 pound structure. He said it was off by 600 pounds. Now, number one, 600 pounds and 120,000 pound structure, I am fine with that accuracy. If I get it that close, I'm happy. Number two, Inventor goes through and does a way better job calculating than any engineer can by hand, because it will actually take out the weight of every hole drilled. If you go through and take the time to add the welds, it will add in the weight of all the welds. So you can get really, really close to exactly what your machine's going to weigh by doing this. You can go in and add virtual components. So if you were going to add something to this, say we were going to fill these things up with water. So I could model these without the water, and then I could go through and add a virtual component and know that these things hold, 500 gallons of water, 5 times 8, I could get the exact 8.42 or whatever it is, do the math and put that in there and know exactly how much of those things are going to weigh full of water even. So you could do all kinds of things like that and get your very accurate weights in there. It'll also do the center of gravity. Tell me where the center of gravity is on this machine. If I turn this off here, see the center of gravity. Tells me if this is centered or not. Can be very important on some machines, and it is based on that. If I come in here and open this up and override something, for example, I open this up and I override the physical. Instead of this weighing 14 pounds, say it weighs 1,400 pounds. Close it out, save it. Turn off my center of gravity, turn it back on. You can see that my center of gravity moved closer to my part because it's much heavier now. So it moved over. It understands that that thing is heavier and it weighs more. So play with this a little bit. It's really easy to use. It's fun to play with. And it's very, very accurate. It can give you some really good information. Everybody has to deal with weight, whether it's shipping, whether it's safety, whether it's the actual machine design itself, whether it's how much material is going into it. If you're designing plastic parts, very important to know how much plastic's going into it if it's a consumer part, because that plastic gets very expensive very quickly if you're going to add a lot of plastic to it. So play with it, see what you can do, see how much your parts weigh, see how much some of the parts we've already done weighs, and see how accurate it is on something you've designed. If you've built something, let me know how that turned out. I believe you can get some really good information from that properties.